we're looking at ALEKS Homework 8 problem, understanding the qualitative predictions of the Arrhenius equation. For this problem, I don't think that we'll need to use math to solve this problem. I think that this is something that we can just kind of predict in our head. So let me remind you, we're going to be using the Arrhenius equation to work on this problem, even though I don't think that we need to actually solve any numbers here. But it's helpful to look at the Arrhenius equation while we're thinking about this problem. So the first situation is telling us, what if we lowered the temperature? So if the temperature, which is right here, if the temperature went down by 10%, how would that affect the rate of the reaction? And when we go back to ALEKS, you'll see that your choices over here for what will happen to the rate are actually pretty specific. It's not it'll go up or it'll go down. It's pretty specific. But because this is an exponential equation, the relationship between these variables is also exponential, not linear. So first of all, when we lower the temperature of a reaction, it's definitely going to also have an effect of lowering the rate. And because this is not a linear relationship, it's not going to lower the rate by the same 10%. It's going to have a much more significant factor than just 10%. So it's going to be lowering the rate, and it's going to be lowering the rate by a lot. Same type of thing with the second question. So this says we are raising the activation energy. So if we're raising the activation energy, making it harder for the reaction to take place, that's going to increase the rate. No, that's going to lower the rate of the reaction because it's going to slow it down. And again, it's not going to lower it by the same 5%. It's going to have a bigger, a more significant effect. So let's go back to ALEKS and let's take a look at this. We said when we cool it down, the rate will fall more than 10%. It's going to be more significant than 10%. When we raise the activation energy, the rate again will fall more than the amount that we raised the activation energy. Let's look at another one just to make sure we don't have to use any math. So for the first question here, we are raising the temperature. So if we're raising the temperature, that means that the rate of the reaction is going to increase. The reaction is going to go faster, but this is going to have a significant effect, more than the same amount that we've raised temperature. So if we raise the temperature by 5%, the rate is going to increase by more than 5%. All of these are always going to be more than. So here's the last question. Raise the activation energy by 10%. Raising the activation energy is going to slow the reaction down. The rate will fall, and it will be more than 10%. So you got the hang of that.